Okay, in problem number 4, we've got to go back and we've got to rationalize a denominator. So you would normally look at this and say, there's nothing that can be done. But remember, we've got radicals in that denominator, so they have to be gotten rid of first. So what we're going to do is we're going to use what's called the conjugate to eliminate these radicals. The conjugate of square root of negative 7 minus the square root of 2 is just square root of 7 plus the square root of 2. All we do to get the conjugate is change the sign in front of the second term. So we're going to multiply both the numerator and denominator by that conjugate. And so what you'll see is that we're going to multiply them both by the square root of 7 plus the square root of 2. Distribute the 10 across to both of those terms. So 10 square root of 7 plus 10 square root of 2 over, now, since they're conjugates, when we do FOIL, we don't have to do the O and the I. We only have to do the F and the L. Square root of 7 times square root of 7 is the square root of 49. Negative times a positive is a negative. Square root of 2 times square root of 2 is square root of 4. So now we've got 10 square root of 7 plus 10 square root of 2, which cannot be combined, over square root of 49 minus square root of 4. So square root of 49 is 7, minus the square root of 4 is 2. And I'm going to come back down to this end, rewrite the numerator, 10 square root of 7 plus 10 square root of 2 over 7 minus 2 is 5. Now what I can do is I can think of these as two separate fractions. So 10 square root of 7 over 5 plus 10 square root of 2 over 5. And I can reduce anything that's alike. So the 10 and the 5 can be reduced, and that's going to be 2 square root of 7. This 10 and this 5 can be reduced, so that's going to be 2 square root of 2. So the solution is going to be 2 square root of 7 plus 2 square root of 2. All right, so in order to be able to solve problem number 5, we have to recall some of the things that we did early on in the year. We're given 1 plus the square root of 5 over 2 equals 4 over w. So what we've got is a fraction set equal to a fraction. This means that we've got a proportion. The rule that you use for solving proportions is to cross multiply. So we've got w times 1 plus the square root of 5. Now, since I'm going to be solving for w, I don't want to distribute w through to the 1 and the square root of 5 because I'm just creating more work for myself. 2 times 4 is 8. So now I know that I've got w times this quantity. So again, how do you get rid of multiplication? You do division. So what we're going to do is divide out the 1 plus the square root of 5 from both sides. And that leaves you with w equals 8 over 1 plus the square root of 5. But now we got the square root of 5 sitting down there, and we can't have a square root of 5. We have to rationalize this denominator. So the conjugate for 1 plus square root of 5 is 1 minus the square root of 5. So we're going to multiply both the numerator and denominator by 1 minus square root of 5. So that gives, we're going to distribute that 8 to both the 1 and the negative square root of 5. So 8 minus 8 square root of 5 over, now we're foiling conjugates. Again, when you foil conjugates, you don't have to do the I, you don't have to do the L. All you have, or the O and the I. You only have to do the F and the L. So 1 times 1 is 1, plus, or positive times a negative is a negative. Square root of 5 times square root of 5 is the square root of 25. So that leaves us with 8 minus 8 square root of 5 over 1 minus 5. So now just go ahead and do as much as you can here. 8 minus 8 square root of 5 over 1 minus 5 is negative 4. 8 divided by negative 4 is negative 2. Negative 8 divided by negative 4 is positive 2. So the solution you're left with is negative 2 plus 2 square root of 5. In our next section, we're going to do some distribution and some FOIL, but this time we're doing it with radicals. So nothing really changes here. You just have to remember your rules to simplify the radicals when you're done. So we've got the square root of 10 times the quantity square root of 6 plus 3. So all we're going to do is just distribute that square root of 10 through to the square root of 6 and to the 3. So square root of 10 times square root of 6 is the square root of 60. Let's see if we can get that a little bit darker there. Plus 3 square root of 10. So now what I've got to do is take a look at that 60 and figure out, are there any perfect square factors that I can factor out of 60? Is there any way of simplifying this? So 1 and 60, 2 and 30, 3 and 20, 4 and 15, 6 and 10. All right, sorry, still got 5 and 12, and 6 and 10, 7, 8, and 9, we'll not go into 60. So 60, 30, 20, 15, 12, 10, 6, and 5 are not perfect square factors, but 4 is. So we can change this to the square root of 4 times 15 plus 3 square root of 10. Square root of 4 is 2, so 2 square root of 15 plus 3 square root of 10 will be your simplified answer on that problem. Over here on 3b, we're going to FOIL. So square root of 6 times the square root of 6 gives us the square root of 36. Square root of 6 times the square root of 3 is positive square root of 18. Negative 2 square root of 3 times the square root of 6 is negative 2 square root of 18. And then negative 2 square root of 3 times the square root of 3 is negative 2 square root of 9. So let's go ahead and do as much simplification as we can do on this. Square root of 36 is 6. Square root of 18 minus 2 square root of 18 is minus the square root of 18. And then negative 2 times the square root of 9. The square root of 9 is 3. So negative 2 times 3 is negative 6. 6 minus 6 is 0. So now we've got the square root of 18. So we've got to simplify this. This is going to be 2 and 9 are going to be our perfect square factors. So we get the square root of 9 times 2, or 3 square root of 2. And that's going to be the simplified solution for that set of binomials. So in problem number 3b, we're just going to FOIL. We've got square root of 6 times the square root of 6, which is going to give us the square root of 36. Square root of 6 times the square root of 3 is positive square root of 18. Negative 2 square root of 3 times the square root of 6 is negative 2 square root of 18. And then negative 2 square root of 3 times the square root of 3 is negative 2 square root of 9. So now we're just going to simplify it as much as we possibly can. Square root of 36 is 6. Square root of 18 minus 2 square root of 18 is negative square root of 18. Then negative 2 times the square root of 9. The square root of 9 is 3. So negative 2 times 3 is negative 6. The 6 and the negative 6 cancel out, and all we're left with is negative square root of 18. Well, the perfect square factor that goes into 18, or the largest perfect square factor that goes into 18, is 9. So we can change this to negative square root of 9 times 2. Square root of 9 is 3, so we get negative 3 square root of 2. This is going to be the simplified form of those binomials.